Hey everyone, Captain Code here. Today we are building a Cli Tetris game in C. As you probably already know, Tetris has a 10 by 20 grid board and 6 objects each containing 4 blocks. We call these objects tetrominos. Tetrominos drop down on the board, and every time an entire line is filled, that line is cleared out and everything above it drops down by one line. Now, first of all, we have to develop some sort of key press handler. Then we are going to develop the game logic, and finally some sort of CLI renderer, if you will. So let's get coding. We're going to need a very minimal CMake file with a bunch of headers and implementation files. Now let's go on to the key press handler. The handler itself should be passed in as a function pointer. We need both the handler itself and a boolean telling us when we need to close a thread. The key press loop is a function running in our separate thread. And of course, we need a function to create the listener thread and another to join it. For the key press itself, it's nice to use getch, which is only available on Windows. But for Unix-like systems, we can create our own getch. So if the game is being built for a non-Windows system, we need to simulate the behavior of getch. So basically, we need to get character inputs without needing a new line. Now, I don't want to focus too much on this part. First, we need to save the current terminal settings. Then we need to disable canonical mode, which means no enter is required for input. Then we need to apply the modified settings. Now we're going to read just one character. Then we're going to restore the terminal to what it was and return the red character. Now we define our key handler struct. The key press loop consists of a simple while loop. And in each iteration, it gets a character and passes it to the handler function. It's in add key press listener that we create the thread. First we fill the struct, and then we try to create a new thread for the key press loop. Now joining the listener is actually quite straightforward. So, now that we are done with the key press listener, let's create a main file and test it all. Of course, we need to create a simple handler function, which is going to consist of a switch case structure. Now we are going to create our thread, and of course we are not going to forget error handling. A simple while loop that will eventually become our main game loop. For now, it's just going to increment an iterator and print it. Oh, and of course we're going to need a delay. I guess a 1 second delay is good enough for now. Usleep works with nanoseconds, so we need to multiply by 1000. At the end we need to join the listener. And now we can do a test run. And of course there are always problems. We just have to move the main file to the src directory. Now it seems to be working fine. And it quits with Q. So the first step is done. So let's get started with the game logic. Let's define values for our width, height, maximum width and height of a tetromino, and the number of tetrominos. we're going to define an enum for the game state. And a tetromino can be defined by its type, width and height and rotation, and its coordinates. We need access to the level and score from the renderer. And we'll need to init the game, terminate the game, toggle pause and play, get the game state, drop the tetromino by one row, move the tetromino to left and right, rotate the tetromino, update the game, and get the value of a particular cell in the table. Now let's just quickly get rid of all the unnecessary errors in Vim and get to the game logic implementation. First, we need to quickly recap the precise rules of the game. The classic Tetris games runs at 60 frames per second. Removing each 10 lines gets us to one higher level, and the game speed changes based on the level we are at. The score is calculated based on the number of lines removed in one move, multiplied by the level plus 1. I think it's a good idea to have every tetromino design in a constant array. We just need to track where the cells are and aren't with zeros and ones, and of course one orientation per tetromino design is enough. Another constant array for scoring per number of removed lines, and another for the speed of the game based on the level reached. Now we initialize the game state variables, including the tetromino, the board, the number of removed lines, the level, the score, and the game state itself. We need a simple getter for the game state. Terminate game simply changes the game state to terminated. And toggle pause should change the game state if it's not terminated, and if it is, it'll just initialize a new game. To initialize the game, we need to clear the board and reset the game state variables. And of course, initialize the tetromino. Every time a tetromino is initialized, its type and orientation will be random. We'll need to calculate its width and height based on its design. And it will be set on the middle top of the board. Now let's just quickly define min and max. Now for get cell, each cell is either on the tetromino or it is already embedded to the board. So we need a static function to determine whether a coordinate is present on the tetromino. It's going to be useful to know the exact range of the tetromino on the board. So the get tetromino range function will give us the starts and ends for x and y coordinates of the tetromino. We need to keep in mind that the width and height will be switched by each rotation. And we'll define the coordinate of the tetromino as its middle point. So now we can get the range of tetromino anywhere on the code we need. Obviously, the tetromino will not include a block on a coordinate that is outside its bounds. Otherwise, we'll calculate the relative inbound coordinates and we'll have to account for the rotation. Now let's take a look at what actually happens when we rotate a tetromino clockwise. As you can see, these are the original and rotated coordinates. And since we are going to translate back the rotated coordinates to the original ones, our new x will be the previous y, and our new y will be the width of the tetromino minus x. So that's exactly what we do in every iteration. And at the end, we account for the negative values. And finally, we just have to check if the relative coordinate is filled on our tetromino design. And we have to make sure our tetromino does not collide with any blocks already on the board. For that, we can define a new static function. Knowing the range of the tetromino is going to be useful again. And we can check if there is any cell within the range that is both on the tetromino and on the board. And now we'll know if the tetromino is somewhere it shouldn't be. The move function should also only work if the game is in the running state. And we make sure that we are not moving it outside the bounds of the board, again using the tetromino range function. If it is outside the bounds, we just undo our move. Rotate tetromino is another function in which it is important to check if the game is in the running state. Since we handled the orientation logic inside the onTetromino function, here we only have to increment the orientation by 1 and move the tetromino back inside the bounds if it passes the borders. And of course, if it collides with the board, the rotation is illegal, so we just undo it. We should only update the game state if the number of frames passed since the last update passes the current game speed. So we need another static function to get the game speed. So now we can try to drop the tetromino by 1 row. If the drop is not successful, that means the tetromino has hit something. So we first check if the tetromino has hit something without completely appearing on the board. That is our game over condition. Otherwise, we need to lock the tetromino to the board, for which we create another static function. Here we can just utilize our getCell function to get the blocks both on the board and on the tetromino. And we also need to remove lines and collect our score. The score is simply calculated based on the removed lines, multiplied by the level plus 1. To remove lines, we loop over the rows and check if the entire row is filled. If it is, we rewrite the entire table on top of it to move every row on top down. And we increment the number of removed rows. And since we need to recheck the same row index, we increment I as well. We know that each 10 removed lines are equivalent to 1 level, and we initialize another tetromino. Now let's update the main file for our game logic. We need random numbers based on time. We have to initialize the game at first, a frame counter variable, and update the game based on the frame. We'll need to implement a draw function later. Now we update our key press cases with our game functions. So now the game logic is also done, and we can move on to the renderer. Our simple renderer will only have a draw function. And here we can use the power of emojis to get a beautiful CLI game. For the draw function, first we have to clear the screen, print out the score and the level, and then loop over the board and print the right color using the getCell function. It will be also nice to have a message underneath based on the game state. We add the draw function to the main file, and the renderer is done. Now there are a couple of things we have missed. Our delay should be 1/60th of a second. There are a couple of name mismatches here. And now we can build and run. And it seems to be working fine. Thanks everyone for watching. I'm new to this video making thing, so if anyone has a suggestion or there's anything you're interested in seeing, please let me know down in the comments. If you stay till the end, please like and subscribe. I'm looking forward to making more videos for you guys. Thanks for having me, I'll see you around.